Hi everyone, this is Dr. Nock, and we're going to go over section 8.3, trig equations. So the definition of the trig equation is that equation involving trig functions, and the solution to trig equation is the values that satisfy the equation. Okay, so let's just go over example number 1 and determine whether theta equals pi over 6 is a solution of 2 cosine of theta plus 1 equals to 0. Okay, so you're going to have to plug it in, pi over 6, into where you see theta, and then make sure that the equation holds. So let's just do this. So when theta is pi over 6 is 2 cosine of pi over 6 plus 1, is it going to equal to 0? This is what you need to be asking. So let's go. So ready? So this is cosine of pi over 6 is root 3 over 2 plus 1. Is it equal to 0? And this is going to be what? Square root over 3 plus 1. Well, that is so not 0. Alright, so therefore, pi over 6 is not a solution. Just like when we're learning about intermediate algebra, you're given some value of x and make sure that, when you plug that x in, equation satisfies. We're doing the same thing but involving trig functions, and that's all. Okay, so moving right along, let's go with example 2. Solve sine of theta equals a half, and give a general formula for all the solution and list 4 of the solutions. Alright, so let's take a look at sine of theta equals to 1/2, which is, remember, opposite over the height. Now the difference between this problem and the problem you used to do, we want to get all the possible solutions. So let's just do this example, maybe it'll make sense. So step number 1, notice that the sign is positive. Sine of theta is positive in which quadrant? So let's just draw it out. So you got all student take calculus. So sine is positive in quadrant 1 and quadrant 2. Okay, and what? Our theta is going to be what? Pi over 6, because if it's opposite over the hypotenuse, opposite side of the angle has length 1, hypotenuse has length 2, so this is that 30, 60, 90 triangle. So this theta, I don't know if you can see this, sorry, so this theta is pi over 6. Okay, so what you need to do is you're going to have to draw the triangle. In both quadrant, pretend those are the same triangle. Oh my goodness. Alright, so from here to here is theta equals to pi over 6. And also the terminal point, another one would be from, let me change the color, from here to here. Okay, so since this angle is pi over 6, the remaining angle is going to be pi minus pi over 6, which is 5 pi over 6. But we want to get all the possible solutions, so let's just look at the first angle, which is pi over 6. Do you see that you can get to the same point if you revolve from this point right here, and then if you add 2 pi to it, because the period of sine is 2 pi, And then what? If you revolve 4 pi, you're still going to get to the same point, and so forth. And same thing as the theta equals to 5 pi over 6. So starting from this point, and if you add 2 pi to it, you're going to get back at the same place because period of sine is 2 pi. Don't worry, I'll write that out. Okay, so since sine function has a period of 2 pi, remember we want to get all the possible solutions. So all solutions, I'm just going to write like that, that's a solution of sine of theta equals 1/2 r. Okay, so starting from theta equals pi over 6, and then you're going to add 2 pi, multiples of 2 pi. So how do you denote that? Is 2 pi k, where k is an integer. Integer means 0, -1, -2, 1, 2, 3, and so forth. And then also theta equals 5 pi over 6 plus 2 pi k. So these are all the possible solutions that we can get. Let me just box that. And now list 4 of the solutions. So it doesn't matter what k value that you're going to take. So let's take k equals to 1, and I'm going to plug it into theta equals to pi over 6 plus 2 pi k. So then here you're going to have theta equals pi over 6 plus 2 pi, k is 1. Okay, so in this case, what is that? Pi over 6 plus 2 pi, 13 pi over 6. Alright, so this is one solution. Now let's go with k equals to 2. Then you're going to have theta equals to pi over 6 plus 2 pi times 2, which is going to be, what is that, 4 pi. So we're going to get 25 pi over 6. I'm running out of room. Now let's take k equals to 1 into this the second solution. So our theta is going to be, that's a 5, sorry. So here we go, 5 pi over 6 plus 2 pi times 1 is just 2 pi. So what do we get? 17 pi over 6. And another one, I'm just going to do it over here. Now when k equals to 2, we're going to get 5 pi over 6 plus 4 pi, because we're going to multiply here by 2. So you're going to have what? 29 pi over 6. And there you have it. So here are the 4 specific solution for sine of theta equals to 1/2. So let me just box each single one of them. And that's what the question's asking you to do. Let's increase the level of difficulty just a tiny bit. So example 3, solve 2 sine theta plus 1 equals to 0. Now in this case, we're only going to pick the solutions between 0 and 2 pi. Alright, so let's get started on this. So if I start out with 2 sine of theta plus 1 equals to 0, subtracting 1 from both sides, we're going to have 2 sine of theta equals to -1. Now that implies that sine of theta equals -1/2. Okay, now sine is negative, so let me just do the same thing as what we usually do. Sine of theta is negative in quad, which one is that? 3 and quadrant 4. So let's draw that out. So let me just circle it. Okay, so sine of theta equals -1/2. So this is same thing as negative of the opposite over the height. But in any case, notice that our theta is going to be negative pi over 6. So let me write it as our theta is going to be negative pi over 6. But now let's look at our given interval over here. Theta equals negative pi over 6 is not inside of 0 to 2 pi. So what we need to do is we're going to have to come up with another angle that has the same terminal point as when theta equals to negative pi over 6. So let me just draw that out. And draw the same triangle on this. I pretend they're the same thing. Oh my gosh, it's so off, sorry. Alright, so from here to here, it's going to be negative pi over 6. But this is not good enough because theta is negative. It's outside of our bound. So what we need to do is you're going to have to come up with another angle that has the same terminal point as negative pi over 6. Okay, so in this case, what we're going to do is you're going to revolve around. And we want to get to here. So what is that angle? So you can do it by 2 pi minus pi over 6. It should give you that angle. So our theta, let me just write it in color coded here. So our theta in this case, let me just erase that one. So 2 pi minus pi over 6. So what is that going to give us? 11 pi over 6. Okay, so keep that in mind. And 11 pi over 6 is inside of 0 to 2 pi. Okay, now let's deal with the other terminal side, which will be right here. Okay, so our angle theta is going to be from the initial side all the way up to down to the terminal side. So since this angle right here is again pi over 6, so how do I determine that angle? Let me just write it over here. Our theta can be determined by pi plus pi over 6. I'll just write it out. So that's 7 pi over 6. And this is inside of 0 to 2 pi. And I believe that's pretty much it. So our solution set, so therefore, solution set is 7 pi over 6 and 11 pi over 6. Okay, now let's look at another example. So let's call this example 4. Solve cosine of theta plus 1 equals 0. And theta is again between 0 to 2 pi. Okay, so let's follow it through. So cosine of theta plus 1 equals to 0. So that implies that we have cosine of theta equals to negative 1. And we want that theta to be between 0 and 2 pi. Now there are a couple ways that you can solve for theta. I personally, when I have cosine of theta equals to negative 1 or 0 or 1, I just look at the cosine graph. So looking at the cosine graph, you don't have to do it this way. You could also use the unit circle if you want to. So cosine graph is going to start from 1, negative 1. So here you're going to have, alright, so this is y equals the cosine of theta. Now, cosine of theta equals to negative 1 when theta equals to pi. Okay, so that's going to be just our answer. So that implies that our theta is going to be pi. And yes, you're going to have another negative 1 value appearing, but you only care from the interval from 0 to 2 pi for this problem. So you just pick pi. And on my notes, in my notes, I've drawn you the unit circle to solve it, so feel free to take a look at it. But in any case, our solution set in this case is going to be just pi. Okay, let's do another one. So let's call this one example 5. Solve 5 cosecant of theta minus 3 equals to 2, and then again theta between 0 to 2 pi. So let's just take a look at that. So let's solve for the cosecant, and here what we're gonna get is 5. Now dividing 5 on both sides, then we're gonna have cosecant of theta equals to 1. which is same thing as 1 over sine of theta equals to 1. But 1 is same thing as 1 over 1 now, isn't it? So basically what we need to do is just solve for theta such that sine of theta equals to 1. And that theta value is going to be our answer. So let me just circle this. We need to determine at what angle theta is our sine going to assume 1. Okay, so again, you can look at the sine graph if you want to. Okay, so if you look at the graph, okay, sine's going to go this way. Okay, so sine of theta equals to 1, that will be right here. And our angle theta must be pi over 2. So our theta is going to be pi over 2, and we're done with the problem. Or if you like to use the unit circle, okay, pretend that's a unit circle. Oh my goodness. So that's 1, 1, -1, and -1. Okay, so remember sine of theta is what? Y over r. Our r is always going to be 1 because we're talking about the unit circle. So sine of theta equals to 1 means that it's same thing as 1 over 1. Now when does y assumes 1 on the unit circle? That will be right here. So you could measure your angle from here to here, and then again theta is going to be pi over 2 regardless. Okay, so therefore our solution set is going to be just pi over 2. Okay, let's do another one. Example 6, solve 4 sine theta plus 3 root 3 equals to root 3 theta between 0 to 2 pi. So let's first try to solve for sine. So we have 4 sine of theta equals root 3 minus 3 root 3. So that's what? -2 root 3. Oops. Okay, remember there is a little invisible 1 sitting here. So this is same thing as what? Factoring out the square root of 3, and then you just basically go 1 minus 3. That's how we get -2 root 3, in case you're wondering. Let me just erase this. Okay, let's keep going. So that implies that, oops, our sine of theta is -2 root 3, whole thing dividing by 4, reduce. So it looks like what we need to solve is sine of theta equaling to negative square root of 3 over 2. Okay, so which is opposite over height. Okay, so let's take a look at that. So this is telling you the opposite. Those of you who like to use a triangle, opposite side has length square root of 3, hypotenuse is 2. This is again a triangle that's familiar to you. So our angle theta here is going to be what? Pi over 3, 60 degrees. And let's keep doing the same thing. So sine of theta is negative in, where is it? Quad 3 and quad 4. Let me just double check. All student take calc. Okay, so sine is definitely negative in quadrant 3 and in quadrant 4. So what we need to do is you're going to have to revolve negative pi over 3 units from the initial side. So let me just draw this. Okay, so this is going to be the point that we're talking about, and angle from here to here is negative pi over 3, and from here to here is also negative pi over 3. That's how much we're revolving. But the thing is, negative pi over 3 is not inside of 0 to 2 pi, so let me just write it out. Okay, so what we need to do is we're going to have to come up with another angle that has a same terminal side, and it's between 0 to 2 pi. So to get to this terminal side here, let me just draw this angle like this. I hope you can see this color. I'm gonna have to go like that. All right, so let's just color code it. So our theta, it's same thing as what? 2 pi minus pi over 3. Which is 5 pi over 3. And 5 pi over 3 is definitely inside of 0 to 2 pi. So this one is a keeper. Now let's go with the other terminal side. So now we're talking about this terminal side now. Okay, so let's go from here. Oh, sorry, can you see this okay? From here. Okay, so let's just call this one theta. So this one, you know, you can do whatever you like. You could just go pi plus pi over 3 if you want. So in this case, our theta is going to be what? 4 pi over 3. And 4 pi over 3 is definitely inside of 0 to 2 pi. So that's going to be our answer. Let me just write. Therefore, the solution set is going to be 4 pi over 3 and 5 pi over 3. How you guys all doing? I hope you're getting a hang of it a little bit, and try the next problem on your own to see if you can do it. So let me just write down the problem. So let's go with example 7. So solve for cosine square of theta minus 3 equals to 0, theta between 0 to 2 pi. So pause the video and try this on your own. And for this particular problem, keep in mind that you are going to have 4 solutions. Okay, let's go over this. So first, I'm going to solve for the cosine. So let's go move the 3 on the right hand side. Oops. Okay, then dividing by 4. Okay, next step, be careful because remember this property. If you have something like x squared or x to the 4th or x to the 6th, the eventh power equaling some number k, then when you take the square root of it, you're going to get plus or minus the square root of k. Not just the square root of k, you're going to have the minus side as well. So with that said, if you take the square root on the cosine squared, we're going to get cosine of theta is plus or minus square root of 3 over square root of 4, which is going to be 2. So we're going to have to get all the values where the cosine is positive and also negative. So we're going to have to take a look at all 4 quadrants for this problem. But anyways, what will be the angle theta here for the reference angle? So our theta, it looks like, so let me see if you want to do the triangle. Cosine is what? Adjacent over hype, or you can just memorize the chart if you want to. So the adjacent side has square root of 3, hypotenuse is 2. So again, this is 60, 30, 90 triangle. So our theta, reference angle, is going to be pi over 6. Okay, so keep that in mind, and let's take a look at the quadrant. Okay, so first I need to revolve pi over 6 units to get to this terminal side. So let's label this. And then I'm just going to draw the triangle. Okay, and then you're also going to have to go pi over 6 units in the quadrant 2 as well. So this is going to be the terminal side. So, and then, so from here to here is again pi over 6. And then in quadrant 3, oops, I'm gonna draw the same triangle where the angle is pi over 6. And let's do the same thing on this side. Okay, so it looks like one of the angle is going to be pi over 6, and the next one, so you're going to have to start from the initial side and to the terminal side would be here. Okay, so this angle theta is going to be what? Pi minus pi over 6, which is 5 pi over 6. And that's between 0 to 2 pi, so we're good. All right, so the next one, next terminal side. Oh my goodness, how am I going to do this? Okay, let's go in here. I don't know if you can see this or not. So let me take this theta down here. So the theta is pi plus pi over 6. So that's 7 pi over 6. This one is a keeper as well. Okay, so the next one, let's go from, oh my gosh, from here all the way to here. All right, so that angle, so I'm going to bring it over here. So that angle theta can be determined by what? 2 pi minus pi over 6, which is 11 pi over 6. All right. So I think that's pretty much it, because if I add multiples of 2 pi, you're just gonna be outside of the range of 0 to 2 pi. So our solution set is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. How did you do on this problem? I hope if you couldn't do it correctly, I hope you can try to redo this problem if you didn't do it correctly. Next example, solve tan of theta over 2 equals root 3, theta between 0 to 2 pi. Okay, so first, let me call this alpha. So let's just go with, notice that, note, tangent of alpha is square root of 3. That's same thing as what? Square root of 3 over 1. Tangent is opposite over adjacent. I'm just trying to get the reference angle here. So the adjacent side of the angle is 1. Opposite side is square root of 3. So again, this is, the hypotenuse is always going to be 2. So it looks like our alpha is going to be 60 degrees, which is going to be pi over 3. So keep that in mind. Okay, so now I'm just going to rewrite everything out. So let alpha be theta over 2. Then tangent of theta over 2 is tan of alpha, which is square root of 3. Now, that implies that our alpha is pi over 3. That's what we just discovered. But what was our alpha? Alpha was theta over 2. So we have theta over 2 equals to pi over 3. Remember, we're trying to solve for theta. So what we need to do now is multiply both sides by 2 to get theta equals 2 pi over 3. So let me just box that. I don't want you to get confused between alpha and theta, because let's just draw this out and let me just try to explain. All student take calc. Okay, so if you just look at the alpha, tan of alpha is √3. That means that tangent is positive. That is in quadrant, which one? 1 and 3. So reference angle is pi/3. And then you're going to have to go pi/3 units this way. Okay, but we're not talking about the alpha. We're talking about theta. So theta is going to be 2 pi/3. So that will be, let me just put this in red. Now 2 pi/3 is going to be in quadrant 2. So this was our alpha. And this is our theta. So notice that our theta, if I revolve 2 pi from that same terminal point, it's certainly going to go above 2 pi. So our solution set in this case is only 2 pi/3. So let me just write it out. I just didn't want you to get confused between alpha and theta, and that was all. So therefore, our solution set is 2 pi/3. Okay, let's do another one. And this one's going to be a little bit more involved, but we got this. Okay, so let's try to solve secant of 3 theta/2 equals -2, and same domain for theta. Okay, so first we're going to try to come up with the reference angles, but first let alpha be 3 theta/2. Okay, and then note that secant of alpha is -2. That's same thing as saying that 1/cosine of alpha is -2. So that implies that cosine of alpha is going to be -1/2. Okay, so let's try to find the reference angle for that. So the cosine is adjacent over height. So adjacent side has length 1, hypotenuse has length 2. So again, this is going to be 30, 60, 90 triangle. So our alpha, the reference angle, is going to be pi/3. So this is the reference angle. Okay, now since cosine is negative, let me just draw the positive quadrant. Okay, cosine is negative in quadrant 2 and quadrant 3. Okay, so our reference angle of pi/3, so it's gonna go like this. So from here to here is our alpha, which is pi/3. And again, from here to here is pi/3 as well. Okay, so now let's try to find the angle. So, oops, the angle from here to here will be, let me just write it, where can I squeeze this in? Maybe I'll just write over here. So our alpha is same thing as pi minus pi/3, which is 2 pi/3. And then let's just put 2 pi k in case we could get more than one answer. So this was our angle alpha, and then to the second terminal point, we're gonna go from here all the way down to here. So let's also call this one alpha as well. So in this case, where can I bring this? I'll just bring it over here. Our alpha is same thing as pi plus pi over 3. So this is 4 pi over 3. And we're going to get to the same terminal point by adding 2 pi, multiples of 2 pi. So I'm just going to leave it as that. Okay, so keep that in mind. And let's try to rewrite this nicely and try to solve. Okay, so I'm going to start from the very beginning. So I'm going to say let alpha be 3 theta over 2. Okay, so that implies that secant of 3 theta over 2 equals to negative 2. And secant of alpha is negative 2. So we just worked it out. So that implies that our alpha is either 2 pi over 3? Was it? That's a pi. My goodness, my handwriting is just getting whack. Okay, so first alpha was what? 2 pi over 3. So 2 pi over 3 plus 2 pi k. K is an integer. And then another alpha, let me just go like this. Another alpha was 4 pi over 3 plus 2 pi k. That's what we just discovered by using this chart. Okay, but the thing is, alpha is 3 theta over 2. So replace. Now, since we need to solve for theta, we need to multiply everything by 2 over 3. So let's do that. So here is, I'm going to multiply here by 2 over 3. And I need to multiply this whole quantity by 2 over 3. And this whole quantity by 2 over 3. Okay, so if I do that, you know what? I'm going to need a little more room. So let me just go onto the next page, and then we'll just continue on from there. Okay, so let me just rewrite everything out by multiplying by 2 over 3. Then what we should get is our theta is going to be 4 pi over 9 plus, I need to multiply by 2/3, so you're going to have 4 pi k over 3. And then another one will be 8 pi over 9 plus 4 pi k over 3. Yuck, it's looking so ugly, right? Okay, remember, we're going to have to take all the possible value of theta that's between 0 to 2 pi. So let's see, let's start plugging in some values for k and figure it out which one we should be keeping. Okay, so let me just box this because this is a very important solution. Okay, so now let's start out with when k equals to 0. Okay, so I'm going to plug it into both. So our theta is 4 pi over 9 plus 4 pi, multiplying by 0, sorry. Why did I just write that? But anyway, so this is just going to be 4 pi over 9. So let me just erase that. Okay, and then another theta is going to be 8 pi over 9 when k is 0. Now, are they inside of 0 to 2 pi? Yes, I think so. So these guys are keepers. All right, so now let's go with when k equals to 1. Oops. Okay, so when k equals to 1, what do we get here? So our theta is 4 pi over 9 plus 4 pi over 3. So that's going to give us what? 4 pi over 9 plus 12 pi over 9. So this is going to be 16 pi over 9. You can convert that into a degree measure if you like, but this is inside of 0 to 2 pi. Okay, now let's go with the other angle theta. So this theta is going to be 8 pi over 9 plus 4 pi over 3. So this is going to be 8 pi over 9 plus 12 pi over 9. So this is 20 pi over 9. Okay, so can you tell that whether this theta is inside of 0 to 2 pi or not? It actually is not. Okay, so let me just write it. This one is not in 0 to 2 pi. So that means if I increase the value of k, then none of those angles are going to be between 0 to 2 pi, because when k equals to 1, another angle theta went overboard. Already overboard meaning went over 2 pi. Oh, so just in case you're wondering, how do you know that this is not inside of 0 to 2 pi? Remember how to convert this into a degree measure? So 20 pi over 9 multiply here by 180 divided by pi. So you're gonna have what? Pi is gonna cancel. 180 over 9, that's gonna give us what? 20. So we have 20 times 20, which is gonna be 400 degrees. That's not in 0 to 2 pi. That's how I knew that it was not inside of that given interval. Okay, so let's move on to the another example. Examples after examples. Okay, so let's try to do example number, this one will be what now? Example 10. Okay, let's go with solve. Sine of, let's look at something a little bit different. 3 theta plus pi over 18 equals to 1. Theta between 0 to 2 pi. Okay, so again, I'm going to start this problem by calling this alpha. And note that sine of alpha equals to 1 when alpha is pi over 2. So let me box that. And let's start the problem. Let alpha be 3 theta plus pi over 18. Okay, then sine of 3 theta plus pi over 18 equals to 1 becomes sine of alpha equals to 1. And we just figured out that alpha is pi over 2. Oh, what did I put? Pi over 3? Sorry, I meant to write pi over 2. But alpha was this crazy 3 theta plus pi over 18. So that's equal to pi over 2. And what is the period of sine? It's 2 pi k. So I'm just going to add 2 pi k. Okay, so now our job is to solve for theta. So first, let's subtract pi over 18 from both sides. Okay, so what do we get? So looks like we're gonna have 3 theta equals, what is that, 4 pi over 9 plus 2 pi k. Okay, all right, now solving for theta, we need to multiply everything by 1/3. Okay, so what do we get over here then? So it looks like our theta is going to be, oh, what an ugliness, 4 pi over 27 plus 2 pi k all over 3. Okay, let's box this. Continuing on to the next page, let me just copy and paste what we just got on the previous page. So we had what? Theta equals 4 pi over 27 plus 2 pi k over 3. Okay, so this is what we boxed on the previous page. Okay, so let's analyze. So let's go with when k equals to 0. Our theta is going to be 4 pi over 27 plus 0, so that will be it. So is this inside of 0 to 2 pi? Yes, it is. Okay, now let's go with when k equals to 1. Okay, then our theta is 4 pi over 27 plus 2 pi over 3. So this is what? 4 pi plus 18 pi. Whole thing over 27. So this is going to be 22 pi over 27. So this is still inside of 0 to 2 pi. Okay, so now let's go with when k equals to 2. Theta equals 4 pi over 27 plus, when k equals to 2, we're going to have 4 pi over 3, which is 4 pi plus 36 pi all over 27. So what is that? 40 pi over 27. Let me see, is this in 0 to 2 pi? Yes, it is. So this is still in 0 to 2 pi. All right, so now let's go with when k equals to 3. Okay, so our theta becomes 4 pi over 27 plus 6 pi over 3. So this gives what? 4 pi plus 54 pi all over 27. So this is 58 pi all over 27. Now is that in 0 to 2 pi? No, it is not. So this is not inside of 0 to 2 pi. Again, if you are confused about why this angle is not in it, you can convert it in terms of a degree measure. At least that's what I always do. And you know what? We completely forgot to check the negative values for k. So we started from k equals to 0. Let's check what's going to happen when k equals to negative 1, because it could be inside of 0 to 2 pi. So let's check. Okay, when k equals to negative 1, we're going to have what? Theta equals 4 pi over 27 minus 2 pi over 3, which is 4 pi minus 18 pi. Oh, I could already see this is not going to be inside of it, over 27. So if you subtract 4 pi minus 18 pi, do you see that you're going to get a negative angle? Okay, so negative is definitely not inside of 0 to 2 pi. So I think we got our solution set. So it looks like our solution set is 4 pi over 27, and then 22 pi over 27, and then 40 pi over 27. Okay, that one was a little bit uglier than other problems, but I hope you got it. And if you have any questions, all you have to do is just email me or just give me a call. How about, let's do another one. We're on the roll here. What the heck? Okay. So, more problems we do, better we're going to get at, right? So let's call this one example 11, right? Okay, so let's try to look at something different. Solve 2 cosine square of theta plus cosine of theta minus 1 equals to 0. Okay, so it's a little bit different. So let's start out with, do you see that if I let u equals to cosine of theta, so let's make ourselves a note. do you see that I can rewrite this equation as 2 times u squared plus u minus 1 equals to 0, which is factorable, so which is 2u and a u, and minus 1 and plus 1 equals to 0. So keep that in mind. And let's just tackle this problem. So starting from the very beginning, so I'm going to say let u be cosine of theta. Then 2 cosine square of theta plus cosine of theta minus 1 equals to 0. Can rewrite this as 2u squared plus u minus 1 equals to 0, which factors into 2u minus 1 and then u plus 1. So, which implies that either 2u minus 1 is 0 or u plus 1 is 0. So that implies that, what is it? Our u is going to be either 1/2 or u equals to -1. Alright, so what was our u? U was cosine of theta. So what we need to do is we need to replace the u with the cosine of theta. So you're going to have cosine of theta is 1/2 and cosine of theta equals to -1. Alright, so let's box these two because these are very important information. Okay, so let's solve these separately. So let me just call this equation 1 and this one equation 2, and we'll work it separately. So let's first work on equation 1. Oh, by the way, SDWK, that stands for side work. Okay, so let's go with the side work for circle 1. So what do we got? Cosine of theta equals 1/2. So cosine is positive. Let me see. Cosine is positive in quadrant 1 and quadrant 4. Okay, so what is the reference angle theta? That would be what? Pi over 3. So if you can figure that out, so cosine is what? Adjacent over height. Adjacent side of the angle has length 1. Hypotenuse is 2. So again, we get 30, 60, 90 degree triangle. Good. So this one is going to be pi over 3. So that's going to be our reference angle. So what we need to do is we're going to have to revolve pi over 3 units this way and pi over 3 units this way. Okay, so let me just draw the triangle. Oh my goodness. Okay. So from here to here is pi over 3. And so let's just call that theta. And from here to here is also theta. Okay, so at the first terminal point at pi over 3, our angle that we can get is what? Theta equals to pi over 3. And if you add 2 pi, multiples of 2 pi, you're going to end up at the same terminal point. So I'm just going to leave it like this. And then let's go with the other terminal point, which is going to be over here. Okay, so our theta in this case will be what? 2 pi minus pi over 3, which is 5 pi over 3. So what we're going to get is theta equals 5 pi over 3 and then 2 pi k, where k is an integer. So let me just box these two. Okay, that is just for the equation for circle 1. Now we still gotta deal with equation circle 2. So side work for circle 2, we have cosine of theta equals to -1. So again, if I have sine or cosine equaling to -1, +1, or 0, I usually look at the graph, but you can determine this however you like. So again, cosine of theta equals to -1 when theta equals to pi. Okay, so I believe that theta equals to pi would be the only angle that is going to be between 0 to 2 pi. So I'm gonna box that. That's gonna be our solution, one of the solutions. So therefore, our solution set is going to be, let me see, pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k, and also, oops, pi plus 2 pi k. So this is our theta. Now if you started plugging in k equals to 0, 1, or 2, theta will be inside of 0 to 2 pi only when k equals to 1. You can check that by working it out on your own. But let me just write it. Theta is in 0 to 2 pi only when k equals to 1. Okay, so therefore, our official solution set is going to be pi over 3, 5 pi over 3, and pi. So this is going to be the answer. How you guys doing up to here? By the way, if you're watching the video up to this point, good job. Because I know this section is not the easiest, but you guys are killing it. Do you all have energy to do maybe one more problem or two? Feel free to take a break because I know that this section can be very torturous. So let's go with example 12. So solve 2 sine square of theta equals to 3, 1 minus cosine of negative theta. Ugly. Okay, so first step, let's look at cosine of negative theta. Remember the even and odd function? So note, cosine was even function, so we're going to have cosine of negative theta. It's going to become just cosine of theta because cosine is an even function. Okay, so let me use that property to rewrite this. So now we have 2 sine square of theta equals 3, 1 minus cosine of theta. It looks a little bit more prettier. Okay, so now let me distribute the 3. Okay, so let's stare at this for a little bit. Do you notice that on the left hand side you have sine of theta going on. On the right hand side you have the cosine of theta going on. Now, do you remember from the previous example, example 11? Everything, if you can write this in terms of either cosine or sine, you might be able to factor it. So that's my goal. So let me replace sine square of theta with 1 minus cosine square of theta. That's the Pythagorean identity. So let me just try this. If it fails, we'll try something else. Oops. Okay, so I'll write every step out because sine squared plus cosine squared equals to 1. Okay, so now let's distribute the 2 in. Okay, now let's subtract 2 from both sides. And what do we got? We have negative 2 cosine square of theta equals 1 minus 3 cosine of theta. Okay, so now what we're going to do is let's bring 1 and minus 3 cosine of theta to the left hand side by subtracting 1 and adding 3 cosine of theta. Then what we're going to get is negative 2 cosine square of theta, and then plus 3 cosine of theta minus 1 equals to 0. It looks like if I let u equals to cosine, maybe we can factor this. So let's keep the leading coefficient to be positive. So multiply everything through by negative 1. So we're going to have 2 cosine square of theta minus 3 cosine of theta plus 1 equals to 0. All right, I think we're good to go. So I'm going to say let u equals cosine of theta. Okay, then I can rewrite this as 2u squared minus 3u plus 1 equals to 0. Oh yes, this is so factorable. All right, so what do we get? 2u and then u minus 1 minus 1. Okay, so that implies that either 2u minus 1 is 0 or u minus 1 is 0. So u is 1/2 or u is 1. Okay, so what was our u? Our u was cosine. So replace cosine of theta is 1/2 and cosine of theta equals to 1. All right, so we got two things going on again, just like the previous example. So let's just call this one circle 1 and this one circle 2, and we'll just work it separately. So let's first do the side work for circle 1. So we have cosine of theta equals to 1/2. So our angle theta, our reference angle, is going to be pi over 3. Okay, so let me just draw you a picture. Again, cosine is positive in quadrant 1 and quadrant 4. So what's going to happen is you're going to have to go pi over 3 units this way and pi over 3 units this way. Okay, so that's going to be our terminal point. So let me just write this in red. So from here to here is pi over 3. And then another angle. If you want me to draw the triangle, I can. So just go like this, go like that. That's 90 degrees. And the other one is going to be from here all the way down to this terminal side. Okay, so in this case, our theta is same thing as 2 pi minus pi over 3. Or you can go, so you can start from 3 pi over 2 and then add pi over 6 if you want. Doesn't matter. So in this case, looks like our theta is going to be, what is that? 5 pi over 3? Okay, so let me just box this. And let me just box this. Okay, I hope you can see my picture. Okay, so our answer here looks like it's going to be, what do we got? We have our theta is going to be pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. Okay, so let me just box this. Okay, so now let's take a look at side work for 2. Okay, so this one isn't so bad. So we have cosine of theta equals to 1. Okay, so again, I usually look at the graph, but you can do your unit circle business. Okay, so here's 1, negative 1. Okay, so cosine of theta equals to 1 when theta equals to 0. Okay, and then that's it, because 2 pi is not included on this interval. So we cannot pick 2 pi out. So in this case, our only solution that we're going to get is theta equals to 0. And then if I add 2 pi to it, it's going to be above the 2 pi. So theta equals to 0 would be the only answer for equation 2. Okay, so let's analyze circle 1. Notice that if k is 1, do you see that it's going to go outside of 2 pi? So it only works when k equals to 0. And also you can check, when k equals to -1, in that case your angle theta are going to be negative on both cases. So this only works when k equals to 0. Okay, so therefore our solution set is going to be pi over 3, 5 pi over 3, and 0. And that's going to be our solution set. Okay, so let's do another one, and this will be our last example that we're going to go through together. I think 13 examples should be enough. Alright, so let's take a look at something different again. So let's go with solve. If you can hear my dog on the background, I apologize. So here you're going to have tan of theta equals 2 sine of theta. Something looks completely different from all of the previous examples that we did. So let's play with this. Okay, so first notice that tangent is sine over cosine. Okay, so let me just convert tangent in terms of a sine over cosine and see where it's going to take us. Okay, so now I don't want to deal with rational expressions, so I'm going to multiply both sides by cosine. Alright, so let's see what we're going to get here. So that implies that we're going to have sine of theta equals 2 sine theta cosine of theta. Okay, so how about let me subtract sine of theta from both sides, and then what we're gonna get is, if we do that, we're gonna have 2 sine theta cosine of theta minus sine of theta equals to 0. Alright, let's try to factor out the sine of theta. If this method does not work, we'll try something else. So sine of theta, and then here you're going to have 2 cosine of theta minus 1 equals to 0. Oh, I think this is going to work out. So that implies that either sine of theta is 0 or 2 cosine of theta minus 1 equals to 0. Okay, so let me just box that one. And solving for cosine of theta, here you're going to get cosine of theta is 1/2. Okay, so we got 2 things to do again, 1 and 2. Okay, so let's go with the side work for circle 1. Okay, so what do we got? Sine of theta equals to 0. So in this case, theta must be 0 and pi only. You can take a look at the graph if you want to, or you could just memorize the chart or do the unit circle business. Okay, so this is y equals sine of theta and -1 and 1. So the sine of theta equals to 0 when theta is 0 and when theta is pi. Okay, so theta is 0 and a pi, since 2 pi is excluded, so these are the only values that we're going to get from the equation circle 1. Okay, now let's go with the side work for circle 2. Okay, so we have cosine of theta equals to 1/2. So again, our reference angle is going to be pi over 3. Cosine is positive in quad 1 and quad 4. We did this earlier, right? So you're probably getting bored by doing this, but so first terminal point is going to be here, and from here to here is our theta equals to pi over 3, and you're going to have to go from here to here down pi over 3 units. Let me just draw a triangle like this if you want. And another terminal point is going to go, you're going to have to go from here all the way down to here. So in this case, our theta, we just did this one, huh? Theta equals to 5 pi over 3. Okay, so it looks like, oh sorry, what did I write over there? So it looks like our theta, it's going to be pi over 3 plus 2 pi k, and then 5 pi over 3 plus 2 pi k. And on this side, your answer is always only going to be 0 and a pi. Let me box that. Now again, play with the values of k. I usually start from k equals to -1 and 0, 1, 2, 3, and so forth. So if you have k equals to -1, you're going to get a negative angle, so that's certainly not inside of 0 to 2 pi. And when k equals to 0, then both angles, pi over 3 and 5 pi over 3, will be between 0 and 2 pi. Now if you have k equals to 1, trust me, it's going to go outside of 2 pi. So our solution set is going to be 0 and a pi, and this will only work when k equals to 0. Only works. Alright, so here you're going to have pi over 3, and then 5 pi over 3. And there you go. So if you were able to follow up to here, you are in pretty darn good shape. So great job for this section, and I guess I will be talking to you soon. Good job, you guys.